Hi everyone, this is Abrar. Welcome to Abrar Knowledge channel. Today's topic is gauge repeatability and reproducibility, gauge R&R. You know that GRR is used when we have a data which is variable data or measurable data. We can use GRR. This is going to be a part 2 and it's going to be very interesting. Why? Because I have picked up very detailed resources on this topic and we are going to mull over all the things. Please stay tuned till the end. You will get the complete package about GRR. So this is the agenda which we have today. There are three parts. Part one, we will be talking about GRR at the high level, very eagle view, and then we'll followed by key terms and definition. When I say key terms, when I'm referring to what is repeatability, what is reproducibility, what is mean by part-to-part variation, and so on. And sources of MSA variability. This is coming from directly from AIAG, an automotive industry action group, fourth edition. So they have given good references that what are the reasons, what are the causes which can have a variability. Yeah. So and then common mistakes, so which we often make when we pick up the topic of MSA. Yeah. So and then part two, we will be talking about what is type 1 error, what is type 2 error, and there is something sweet, definitions and tips around. There is something called SWIP. We will be talking about that, and then type of GRR. You know that GRR has got three types, so we will be discussing about that, and also we will be discussing the Minitab navigation also as well. The last and final segment is part three. Part three will be talking about quick quiz and then a Minitab demonstration as such. So this is part one. And part one, you know that the gauge repeatability and reproducibility is the combined estimate of two factor. One is called repeatability, one is called reproducibility, right? So repeatability, so we will see that what is the definition of repeatability and reproducibility in the next slide. But you can also remember that GRR, when we can conditionally approve, when we can approve straight away, when we can reject, and all that. There are two factors we need to remember. So when we do GRR, that means it gives only round of value. Like you will get the value of 1, 2, 3, 4, 5, and so on. You will not get the value like 4.2 or 4.1 and 3.2 and so on. So you will get the round of value. Okay. So a hand method, you may probably get the decimal value also as well. Nevertheless, so NDC value, if it is 5, that means we can approve it. In terms of percentage, less than 10 percentage. And conditionally approve if you have a variation between 11 to 30, and then you'll figure out that what is the cost, whether this is cost is unavoidable, inevitable, then you can approve it conditionally by documenting the justification and so on. So this is greater than 2, less than 5. Another one is their case reject anything greater than 30 percentage variation or less than 2, you're going to reject the NDC. So this is the key terms which we need to know about gauge repeatability and reproducibility. So repeatability is the variation in the measurement obtained by measuring the same characteristic of one part multiple times. The same part is going to be repeat. The word repeat is same part is going to measure in multiple times by the same operator, right? Commonly referred as EV or equipment variation, represent as inherent variability of the measurement system itself. So this is repeatability. Same part being measured different time by the same operator. So there is a second term called, this is repeatability. I'm just measuring the same part, same operator with a different time. That is called repeatability. Reproducibility is the variation in the average of the measured made by different operator using the same gauge when measuring one characteristic on one part. That means the same part being measured by different operators, different appraisers, commonly referred as AV, appraiser variations. For example, this bell curve is self-explanatory. Maybe I will pick it up. This is the example of reproducibility, right? So I'm just checking with the appraiser one, two, all these, and combinedly you will get reproducibility, right? So this is a distribution of appraisers averages, right? So all of these, let's say I'm using three appraisers, the averages, that is called, so you will have a observed value in these things, that's called reproducibility. And then in a nutshell, so now these two are very critical and key components of GRR. One is repeatability. We learned that anything which is one part being measured by same operator at different times, and one part is multiple times being measured. Reproducibility is something which is different operator being measured by one same part. So in a nutshell, typically there are three studies performed. Number one, each this is very important conditions I think we need to know. One is each person randomly measures 10 mark part per trial, right? That means n equal to 10. Each person can perform up to 3 trials, but not limited to. But having 1 and 2 may not give a good result, so we can go for 3 trials or 3 or more trials. All parts and trial should be done in random order. This is very pivotal, and we will see that why this factor is so pivotal. Let's say if you're taking the parts sequentially, if you're taking the parts only good parts, what error it can lead to, we will discuss about that. So this is three things we need to keep in mind. So what are the three indicator? You will get it in the charts, right? There are one is called percentage P by T. This is called measurement variation compared to tolerance. So P is measurement variation, and which is compared to tolerance by T, tolerance. And then next term you have percentage study variation or measurement variation compared to process variation, observed value. So number of distinct categories, the whole thing it sum up and gives you NDC, a number of distinct categories or measurement of resolutions. So this is one being picked up from AIAG. So AIAG 220 2010 fourth edition, and this is the source is being coming from measurement system analysis. So for example, measurement system analysis, I'm not going to go through all these one, but quickly I wanted to touch upon few things. Let's say when we say variability, how does that let's say instrument cost state, where does the appraiser cost state, environment, and so on and so forth. Let's talk about two things. One is appraiser or person. So maybe education is a factor, physical is a factor, fatigueness can be factor, experience can be factor, training can be factor, skills and understanding procedures, and all these could be a factor. And when you talk about the instrument we have a multiple factor. One is called bias, stability, linearity, use assumption, common sense, uniformity, and repeatability, of course, reproducibility. And then you have there is environment, like let's say temperature and cycles, how much cycles you take, how much samples you take. All of these could be a factor. So these are all the common mistake which we need to avoid it. So while taking up, for example, 10 consecutive parts, let's say you're making 100 laptops and you wanted to measure, you know, we should typically measure at a random fashion. If you're measuring like 1 to 10 parts, I'm just taking it. The rest 90, I'm taking the decision based on the first 10. So that means what will happen is, let's say you're taking the result, low part to part variation can happen because you're taking continuously consecutive one. Reduce a total variation, and that means it will increase the repeatability and reproducibility percentage. For example, this is one example. All of these 10 things I'm just taking. So for example, if the values are center of the value is 2, if the all the value observed value is outlier, all these can be a problem. So if you're taking random, let's say the same 100 laptops, I've been taking the measurement at a random fashion, representing true part to part variation. So that means the number one factor we need to keep in mind is random. Good estimation, you will get it. Excuse me. Let's say each part can have a variation. That variation can be well within the limit, and we will be able to estimate better. Extreme reference part, we should not use it. For example, artificially, we take the good sample, we take the failure sample and try to measure it. What will happen? Artificially increase the part to part variation, increase the total variation, thereby reduce the same case like what we saw in the 10 consecutive parts. Like this is one example of that. So we need to take the samples at random. So part two, we're gonna talk about type one and type two error and swap. And this is one beautiful terms which you can take home and take away, and it will be very very nice concept to know. And then we'll talk about the type of GRR and the navigation. So this is type one and type two error, which we can have typically while we have the measurement system. Effect of measurement system, variation on product quality or process quality decision. When true part measurement is near specification limit, our measurement system variation can affect the product decision. Can affect. For example, I'm just saying like LSL, there is a outlier. Okay, so that means no, here the observed value is like this, or the observed value is like this. This is the measurement system variation, right? So this is true part variation. So the one what you see here, this is true part, I mean true value, and this is variation. And then what will happen in this case, that means this is a good product and this is a very very good value. Good parts sometimes judge wrong or incorrect. That is called type 1 error, that is called producer risk, right? Another risk you have, let's say observed value is weak enough, and you can see that process variation, this is variation, and then bad parts sometimes judge good. That is called type 2 error or consumer risk. So what we need to strike the balance, we need to strike the balance between 1 and 2, and then we need to hit and target at the middle, right? So why we need to hit in something called 3? There is no something called 3, but metaphorically, when we talk about 3, that means three things we will get it. One, bad parts always will be able to judge bad. Potentially wrong or incorrect decision can be made. Good parts always judge good. So that means we need to judge a part if it is good, if it is good, if it is incorrect, it is incorrect. What is critical factor? For example, sometime you might have seen this is the common phenomena. A common case in functional test is having a unit which fail in first time, or first time when it's tested it fail. There's a laptop being tested for functional test, it failed. And without made any changes, it has been retested. The unit been retested, laptop been retested, and it passed. How could this be happen? So this is called, a typical cause is due to measurement variation overlaps the specification variation or limit. Then a wrong decision can happen. So this is something we can talk about it through process variation, and then you have a measurement system, right? That error. Then both the thing combined together, you have observed variations, right? So there is a tips called SWAP. That means 6 essential element of measurement system. Number one, standard, right? And workpiece, we call them as parts, instrument, person, environment. This may be thought of an error model for a complete measurement system. So these are all the 6 things. So there are 3 types of GRR, you all know. One is called cross method, that is widely used. Cross method, what it does, it is a non-destructive scenario when the parts are not destroyed and during the measurement and can be measured twice, can be measured anytime, can be reuse it, then it is called cross method. For example, when measuring the length of a part, so when we measure, let's say I'm measuring the length of a shirt, so the any number of time if you measure it is not gonna harm the shirt, right? Harm the material. So that is called cross method. The part is not changed during the measurement. And cross method, the word cross method meaning like when you have a different operator, different appraisers or operator, when you have a different test, there is also a cross method. That's how the word cross method has come. Then there is something called nested method. The method is used, maybe I will make this is little bigger. So nested method, this method is used when only one operator measures each part. Okay, only one operator is measured each part. For example, electrical equipments, and that is usually because the test destroys the parts, and only one time you can do it. Let's say surge current and surge electrical product or any product which is very destructive in nature. This is called nested because one or more factor are nested under another factor, not cross with the other factor. When every operator cannot measure all parts, nested is being used. Then you have two combination, one in expanded. So the cross plus nested is called expanded. We'll see the quick definition. When one or more of the following condition exists, for example, you have more than two factor, for example, operator, gauge, part, you wanted to declare some factor or fixed factor, you have both cross and nested factors, and you have unbalanced design that when expanded can be used. But widely cross method is used. And very important tidbit around on this topic, MSA is an analysis of the measurement process, not an analysis of the people. So this is the cross method. Anyway, we are gonna do this one and quickly wanted to go through this one. Let's say this is the value which we will be doing directly in the Minitab. So how to do that? Start and quality tools, cross and gauge study. You will get the cross method. And if you wanted to pick up, this is the typical output window, what you will get it in the cross method. We'll talk about that. So if you have NDC is 1, you're gonna really reject because the variation is too high. Okay, so next you have, there is called nested method. Nested, this when you have something called destructive and you cannot use the test again, then nested tested use. And this is the navigation. Start quality tools and start gauge study, and then under the gauge study you have gauge R&R study nested. And this is the window of this one. For example, in this case we got NDC equal to 6. That's really good. The last and final one is expanded method. In expanded method we can also use when you have a multiple conditions, multiple factors, you can use that. And this is the window, you will get it, the output window, and we will talk about that. And this is lastly we will talk about a quick quiz before we go into Minitab and do a step-by-step demonstration. When conducting a gauge R&R, it is important to, I think I covered this exclusively in the Minitab quiz session, but let me repeat this question again. When conducting a gauge R&R, it is important to, all these are important. What is very important is you need to give the answer. If you are getting it, please do comment. And your time, I mean, 4, 3, 2, 1. The answer is measure the parts in random order. That is very important. And then followed by the part, use at least 10 parts, make sure at least 2 operator participate, and so on. So the next question is the difference between observed average of measurement, the reference value is called precision, bias, repeatability, and linearity. The answer is repeatability. Anything you observed value when you talk about it, so then it is repeatable. Repeatability is the ability of an operator to consistently repeat the same measurement of the same part using the same gauge under the same condition. The last quiz, here we go. Variation in average measurement made by different appraiser, but the same gauge is the measurement of dash. Stability, bias, repeatability, and reproducibility. Can you take a guess? We are talking about variation in the average measurement made by different operator. When you say different operator, the answer is repeatability. Why? The ability of a gauge used by multiple operator to consistently reproduce the same measurement of the same part under the same condition is reproducibility. So let's say an example of Minitab. So how we can do a GRR1. So let's say this is very important that run order has to be done in the random fashion, and this is the part, and this is the operators, and this is the operator name. And when you say one, it is referred to bar and measured and so on. So what we can also give the name also as well. Right? Measured values. These are all the measured values. So what we need to do, we need to go to start, and then you have quality tools inside Gage R&R. The commonly used is Gage cross method. You can pick it up. Part number. So this is the parts, and operator. This is the operator measurement systems, and generally commonly used is ANOVA and Gage R&R. You can say here part two, and maybe studies then December 20 report by Abrar, and gauge tolerance you can say. So here tolerance is, you can say, 0.1. So I'm not gonna give that, and then okay, options. So you can also define the lower limit and upper limit, and then you can also put the GRR, giving the heading like GRR part 2. So storage, if you wanted to store the results here on the one, you can do that. For example, I wanted to store the NDC value, you can do that. So NDC is 7, very, very good. So you can also quickly store the result also as well on the column. So what we have got, so we have got, so I'm directly going into this chart, and here what you can see is repeatability, Gage R&R. So you can see contribution and percentage steady variation, and repeatability and reproducibility fairly good, not much of difference, and part to part variation. And this is R chart, and this is X bar R chart, and then measurement by parts. So there are different parts being measured at different fashion. This is the one, and operator fairly good, and parts variation. So this is the value you will get it. And how do I get the NDC value? So NDC value, you scroll down a bit, you will get the NDC value. NDC value is 7. That is very good value. So this is one quick demonstration of GRR part 2. I hope you like this video. Please do like, share, subscribe my channel. Have a nice day ahead.